Okay, then there's a question related to task 23, and I have already opened up the notes from task 23 here. And the first question is why there is a switch. So someone saw the video already on YouTube, and the question is why there is a switch in the circuit here. Because the task says that the coil with some inductance and so on is connected to the voltage source, and to do this connection we need the switch. So this is the question why we have a switch. And then there's the second question, why is the voltage at the inductor the same as the source voltage and not zero? And so the question is related to this derivation here, or to this derivative, and why the derivative of zero is not zero. Okay, so the voltage drop across the inductor. So here we have the inductor. The voltage drop across the inductor always follows this equation here. So the time derivative of the current. If the current changes through this inductor, then some voltage is induced. And the more inductance, the more voltage, but the more current change, also the more voltage. And at the beginning, if the switch is open, there can be no current. Before the connection, before we connect the inductance with this copper resistance to the source voltage, there is no current, because if there's no connection, there can be no current. So if we close, of course, before opening the switch, the current is zero. If we close the switch, for a short moment, the current must also be zero, because the current cannot jump. The current can only continuously change. But if the current would jump up and down, the derivative of a jump would be infinite. We would get some infinitely high voltage at the inductor, which doesn't make sense. So even if we close the switch for a short moment, the current must still be zero. So if the current is zero, then the voltage drop across the resistor will also be zero. And so therefore the whole source voltage will be visible across the inductor. And so that's why we have, at the moment when we close the switch, we will have the full voltage, the full source voltage across the inductor. And so then we have some voltage here. As we have some voltage here, we will also get a change of current. And so then the current will increase, because we have a voltage, the current will increase. If the current will increase, the voltage across the resistor will increase. Because the source voltage is constant, if we have an increasing voltage here, we will get a decreasing voltage here. It will still be positive, but there will be less change of the current there. And so the current will increase furthermore. So we get more voltage across the resistor, less voltage across the inductor. And if we wait long enough, then current will not change anymore. So then the current is constant. Derivative of a constant is zero. So we have no voltage here anymore, but the full source voltage will be across the resistor, and we will have full current. And so, this is maybe some misconception or some misunderstanding. Even if we have no current through the inductor, we still can have a voltage across the inductor. Because if we close the switch for a short moment, the current is still zero, but it's changing, and that's why we get this voltage here. So the current for a short moment is zero, but the current is changing, and that's why the derivative is not zero. The current itself is zero, but the current is increasing, and so you can, that's maybe the misunderstanding here. the derivative of 0 is 0. Yeah, the current is 0, but it's changing, and that's why the derivative is not 0.